Hello everyone. Today we will discuss some more problems on degree of freedom. The first problem is, let us consider a block and wedge move in vertical plane. This is a wedge. It is making an angle of theta with the x-axis, and a block is placed here. The mass of the block is, say, small m, and the mass of the wedge is, suppose, capital M. The Cartesian coordinates of the block at any instant, say x1, y1, and the distance of the wedge from the OY axis is at an instant, say x2. You know that as the mass m moves in downward direction, the wedge move in XO direction. Okay, so here the degree of freedom will be, because here the number of particles are 2. Here you have to remember that x1 in Cartesian coordinates, x1 and y1 for small m block, one coordinate is independent coordinate and other will be a dependent coordinate. Similarly, as your m is moving, your x2 is also changing, so x2 is also a dependent coordinate. So here only one independent coordinate. So what will be here degree of freedom? By using the formula, it is a two-dimensional case, so it will be 2. The number of particles are 2. So how many restrictions are there? There are 2 dependent coordinates, so their restrictions are 2. So degree of freedom in this case will be 2. The next problem is, let us say the 2 particles are moving on a spherical surface. Suppose this is your x-axis, this is your y-axis, and this is your z-axis. It is the origin of the sphere, and the radius of the sphere, suppose, is capital R, and this is your point 1 and this is your point 2. These 2 points are not joined anyway, they are moving freely on the surface of the sphere. So here degree of freedom will be, because it is a 3-dimensional case, so, and the number of particles are 2, so it will be 3 into 2. Now what will be the constants? The constants here are 2, because the distance of the particle 1 from the origin of the sphere, it is same as the distance of the particle 2 from the origin O, and it is the radius of the sphere. So here the constant we have considered 2, so your degree of freedom will be 4. Next problem is, let us consider the 2 particles are joined by a spring, and they are moving on the surface of a sphere. Again, we will consider a three-dimensional case. This is your x-axis, this is your y-axis, and this is your z-axis. This is particle number 1, say this is particle number 2, this is the origin of this sphere, and let us say the radius of this sphere is r. We know that the spring does not produce any constant, so your degree of freedom will be, because it is a three-dimensional case, so we will use the number 3, and there are two particles. Okay, again here the distance of the particle 1 from the origin is always going to be r, and similarly the distance of the particle 2 from origin O is also going to be constant, but the distance between the particle 1 and 2, it is not going to be constant in case of spring. So here the number of constants are 2, so again the degree of freedom here will be 4. Let us consider the two particles are moving on a spherical surface, but this time they are joined by a light rigid rod. This is, say, x-axis, and this is the origin of this sphere. This is your y-axis, and this is your z-axis. This is point 1, and this is point 2, and the point 1 and 2, they are joined by a light rigid rod. The distance between the particle 1 and particle 2 is always going to be constant. So here now what will be the degree of freedom in this case? Here degree of freedom will be, because it is again a three-dimensional case and the number of particles are 2, but what will be your constant? The constants here will be 3, because the distance between the particle 1 and the origin is, let us say, r. The distance between the particle 2 and the origin is again, say, r, and if the distance between 1 and 2 is constant, it may have any value, but it is going to be constant for the two particles. So here the number of constants will be 3. So here degree of freedom will be 3. Now the next problem is, suppose it is a simple pendulum problem. Let us consider this is the mass of the bob m, and it is moving in xy plane. This is your x-axis and this is your y-axis. This is the origin. So you know that the length of the this string is always going to be constant. So at any instant you can have a relation in xy plane, x square plus y square is equal to L square. So here degree of freedom for a simple pendulum in two-dimensional case, it will be 2. The number of particles here is 1, and the constant here is 1, because here your L is constant. So if you find here y, then you can have y is equal to plus minus root L square minus x square. So here x is only, you can consider x or y as one independent coordinate. So here degree of freedom will be 1. Thank you.